Well, howdy there, Internet students. It's Mr. Hermanson again. I'd just like to go over a couple problems with you that some students had difficulties with from the 7.3D Day 2 practice. Right here, this number 2 problem. Quite a few got that wrong, so let's go over that. And these chemistry problems always cause a little bit of a problem. So let's first of all come up with an equation. Let's start with the kind of a simple part of the equation. X plus y, the total amount of solution is 30, like that. And that solution includes water, so let's let X be our water. And then our 30% solution is part of the mix. So our y is that. Okay? So if we add X and Y together, we're going to have 30 total liters of solutions. Now in the second equation, we're going to measure the fertilizer part. Okay, so we need to have in the end, we need to have 30 liters of 10% solution. So 10% of 30 equals 3. And we're going to get that from our water. We're going to have partially water. But the water part isn't going to represent that solution. The only part of the solution is this 30%. So from that 30% solution, so 30% of Y now you could call water the 0% solution if you wanted to. You could call water 0% solution, so you could take 0.0 times your X, but that would just be 0 anyway, so it's really just the 30% solution that makes that up. So let's go ahead and solve that for Y. So Y equals, divide both sides by 0.30, and we get 10 for that. So we get, if we do 10 liters of that 30% solution, and then 20 liters of water, we'll be good, because we'll have 30 liters total, and 30% of 10 is 3, and 3 out of 30 is 10%. All right, I'm going to do one more problem with you. That problem is the paddling or the swimming one, I think it is. Yeah. It says, while on vacation, Kevin went for a swim. Against the current, it took him 8 minutes to swim 200 meters. Eight minutes to swim 200 meters. Swimming back to shore with the current took half as long. So in other words, it took him 4 minutes. That would be half, right? 4 minutes. Okay, so to find your rate, you have to do your distance divided by your time. So that's a T there. Okay, so we're going to take 200 divided by 8 to get his rate against the current. And that equals 12.5. And then with the current, when he's going the other way across the lake, it's 200 divided by 4, which is, oop, I think I did the wrong math there. That should be 25 there. Sorry about that. 25 meters per minute against the current, and 50 meters per minute with the current. Okay, so now we're going to do our equations, x plus y, so that's with the current, so y is the current. So with the current, he went 50. Against the current, he went 25. This is the perfect thing to use elimination. Just add the two together and you get 2x equals 75. So x divided by 2, x is 37.5. And then your y, they have to add up to 50, right? So your y would be 12.5. And that's meters per minute. All right, hope that helps you. We'll talk to you soon.